this video, we're going to look at graphing a sine function. So we're going to start with just the most basic sine function there is, which is just y equals sine of x. If I'm looking at y equals sine of x, I have to remember on the unit circle, the sine function refers to the y value, the height on the unit circle. So sine of 0 would be 0. Sine of pi over 2 would be 1. Sine of pi would be 0, etc. And so if we're graphing this, there are specific values, specific x values that we would like to have. So I'm going to start with a chart. And in this chart, we're going to have x and y. And the first x value that we would like to have is 0. And if we're looking at the x equals 0, we're looking at the sine of 0. That's for this piece. That gives me y is 0. Then the next one is going to be pi over 2. And if we look at the sine of pi over 2, we're up at the top of the unit circle, so our y is 1. The next is going to be looking at x equal to pi. And if we look at x equal pi, that's happening over here. And so we're getting, that's happening when y is equal to 0. And then we're going to look at 3 pi over 2. And when you're looking at 3 pi over 2, that's happening down here. So the y value is -1. And then the next one that we would care about is 2 pi, which is over here. So our y value is going to be 0. And now we've gone all the way around the circle, and so we have one full period of the sine function. We can graph what this sine function looks like. So now we just start by plotting the points. 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, comma -1, and 2 pi, comma 0. And then we're going to connect these using a rounded sketch to get something like this, and then it would continue in either direction from there and keep going forever, because we could keep going around the circle farther. And so we have the basic shape of the sine graph. Things to notice about the sine graph: the domain. I can plug anything in, go around the circle. Positive goes around the circle in the counterclockwise direction, and negative goes around the circle in the clockwise direction. So my domain is -infinity to infinity. The range is going to be from -1 to 1, because on the unit circle, we never get below -1 and we never go above 1. My period is 2 pi, meaning once you've moved to 2 pi, you just start repeating what you've already done. And I can look at my zeros, and my zeros come in the form of pi times k, comma 0, where k is any integer. So if k is 0, I get a 0 at 0, 0. If k is 1, I get a 0 at pi, comma 0. If k is 2, I get a 0 at 2 pi, comma 0. If k is 257, there's another 0 at 257, comma 0. And so that's all of the all of the zeros. This is the basic sine function. But in reality, we frequently have to deal with a more complicated sine function. So if we add all the complication in that we could see, we could see a sine function that has some kind of a multiplier. I'm going to use A, which stands for amplitude, times sine of omega. Some people will use a B for this. I like omega. Times x minus phi plus some kind of a multiplier, some kind of a translation L. So A tells me the vertical stretch, omega tells me the horizontal stretch, phi tells me the horizontal movement, side-to-side movement, and L tells me the vertical movement. So we are both stretched and translated both horizontally and vertically. So let's look at a specific example. Let's look at the example y equal 2 sine, y equals 1/2 sine is the example I wanted to look at. Y equals 1/2 sine of 2 times x minus pi over 2 plus, well, I want to do plus a negative 1, so let's go minus 1. And if I look at this graph, once again, I'm going to be looking at making a chart of the important angles. And my important angles still don't change. So my important angles are going to be 0, pi over 2, pi, 3 pi over 2, 2 pi, etc. But if I think about what happens when my omega is 2, when my inside multiplier is 2, when my x value has changed by pi, my angle has changed by 2 pi. So to correct for that, I'm going to be dealing with x minus pi over 2. To get to 0, x minus pi over 2 would be 0. To get to pi over 2, x minus pi over 2 would have to be pi over 4. To get to pi, my x minus pi over 2 would have to be pi over 2, because pi over 2 times 2 is pi. Then 3 pi over 4, because 3 pi over 4 is 3 pi over 2. And finally pi, because pi times 2 is 2 pi. But if x minus pi over 2 gives me these, then x must be pi over 2, and x must be, to get to pi over 4, my x must have been 3 pi over 4. To get to pi over 2, my x must have been pi. To get to 3 pi over 4, my x must have been 5 pi over 4. And to get to pi, my x must have been 3 pi over 2. So when x is pi over 2, my x minus pi over 2 is 0. My angle is 0, and so my y value is 0. When x is 3 pi over 4, my angle theta is pi over 2, so my y value is going to be 1. When x is pi, my angle is pi, so my y value is 0. When x is 5 pi over 4, my angle is 3 pi over 2, so my y value is -1. And when x is 3 pi over 2, my angle is 2 pi, so my y value is back to 0. My sine is back to 0. And so what this does for me is it allows me to plot some points. At pi over 2, my y value is 0. At 3 pi over 4, my y value is 1. At pi, my y value is 0. At 5 pi over 4, my y value is -1. At x equal 3 pi over 2, my y value is 0. However, I haven't yet taken the multiplication by 1/2 into account. So my two points that are above the axis and below the axis both have to be multiplied by 1/2 and bring them up to 1/2 and negative 1/2. And then all of these have to be moved down by 1 because of the -1 at the end. So these points all become moved down by 1. And now, if we look at this, we can keep following the pattern to graph this whole distance. And so then we just have to fill in the graph with the appropriate line. And that is the function y equal 1/2 sine of 2 times x minus pi over 2 minus 1. And so if I look at this, my domain is still negative infinity to infinity. My range has now become negative 3/2 to negative 1/2, and that is inclusive. My period, well, it only takes from pi over 2 to 3 pi over 2 to graph one full period, so my period is pi. And my zeros, well, I don't have any zeros because I've moved everything down, so there are no zeros. And that is the graph of y equal 1/2 sine 2x minus pi over 2 minus 1.